innovative things do happen in academia, but they don't do product. Current university administration, they don't care whether you have started a company or not, whether you have done patents or not, right? Every licensing person in a university say, oh my God, I'm going to jack up the royalty, right? So it becomes so difficult for a startup to this, it's not worth it, right? Startups are actually uniquely positioned to do the Horizon 3 disruptive innovation.
Today's guest on the KVKurious Podcast is someone with an illustrious career. Someone who spent 22 years in academia, gone on to start his own firms, have meaningful exits, and eventually gone on to be on the boards or lead as an executive at leading tech corporations. I'm talking about Dr. Professor Prith Banerjee, who was originally a prof at UIUC, Northwestern, and then went on to become the dean at University of Illinois at Chicago. And eventually founded AccelChip and BINACHIP, exited those two firms, licensed those technologies, and eventually headed research teams at Hewlett-Packard, at ABB, at Schneider Electric, and is more recently the CTO of Ansys Inc. This conversation is very interesting to me because academics typically tend to have very strong opinions on why research is critical and research is what transforms the world. But Dr. Prith comes with unique perspectives on how academia and industry need to collaborate and how can they collaborate to accelerate the pace of innovation, accelerate the pace of growth, and accelerate the pace at which the impact of innovations can be transferred or made available to the public and the markets. So listen to this conversation. Oh, and more importantly, if you are someone who's contemplating graduate school, considering pursuing a PhD, you might want to watch this to understand if PhD or academia is a relevant choice for you, and what are some reasons you should consider it, and what are some reasons for which you might not want to consider it, and to identify if you should focus on innovation, what path should you exactly chart out for yourself. So listen to this conversation on the KVKurious Podcast, Dr. Prith Banerjee. Hi, Professor Prith. Thank you for making it to the podcast. Really excited to know more about what has led you to transition from being 22 years in academia to then running startups, exiting startups, then joining tech corporations, to being on the boards of multiple of these corporations, and now the CTO of Ansys. And personally, you being the CTO of Ansys is exciting to me because for almost every MEC student out there, and I'm a MEC grad by training, so our entire undergrad life, we've dwelled on Ansys. Anything we had to do, we used to run simulations on Ansys. It's been a part of almost all of our course projects, including most of our bachelor's thesis. So it's kind of also a privilege to me that I'm talking to you today as a CTO of Ansys. So yeah, I want to know more.
Thank you very much, Krishna. And it's great to speak to you, great to speak to a student who has used Ansys tools. So you asked a question. So let me kind of explain to you and the audience sort of my personal journey and where I landed and how I landed. So I, like you, I'm from India. I'm from eastern part of India, Kolkata. And I did my high school studies in Don Bosco School, and then went to IIT Kharagpur, got a bachelor's degree in electronics and electrical communications engineering, then came to the US to do my PhD at the University of Illinois, Urbana, in electrical and computer engineering. When I graduated, I had a sort of opportunity to either work in academia or in a large company. I had offers from places like IBM Research and Bell Labs and others, and also from about a dozen universities. But I chose to stay in academia because academia provides you sort of the complete freedom to pursue your dreams, right? Whatever research you want to do, you can do that without being told by the corporation. That's kind of why I joined academia. So I spent the first 22 years in academia, first as a professor at the University of Illinois, and then moving through the ranks, became a full professor, then went to Northwestern University as a department head of electrical engineering, then became a dean of engineering at University of Illinois. So the first sort of 22 years in academia, what I learned was how academic sort of professors do innovation, and essentially it's a process of discovery, finding new things, working with graduate students. I was fortunate to work with more than 37 PhD students, lots and lots of publications in sort of top journals, conferences, and so on. And I was absolutely having a great time. But Krishna, what I found was I was doing all this research, publishing all these papers, and getting sort of accolades, right? Fellow of IEEE, fellow of ACM, and so on. But very few of those innovations or discovery actually made it into products to change the world, right? People actually use. So we are doing all these publications, and God knows who was reading this publication and so on. So I'm just making an extreme statement, but that's kind of what motivated me to enter sort of phase 2 in my career, which is the 2 startups. I was fortunate to have founded and started two companies, AccelChip and BINACHIP. And both were based out of research done at the university. And again, I was fortunate to have been able to raise funding from VCs, hire the right talent, build a product, sell the product, and ultimately exit both the startups, right? And so I was personally absolutely thrilled. In both these startups I did while being in academia, took a leave of absence from the university and did the startup, came back, did the second startup, came back, and so on. So that essentially was phase 2 in my career, and that was absolutely transformational because I felt so much excitement about taking a sort of a research project from a university lab and then making it into a product, right? I had people who would use. And the kick I got out of the first copy of, so the first $50,000 check that a customer paid to use the product that my team had built was absolutely fantastic, much better than the 350 publications that I had in IEEE and ACM journals and conferences. So that really changed my life. And that is why I went to the phase 3 in my career to join large companies, right? I was fortunate to have received an opportunity at Hewlett-Packard to run HP Labs. Now, Krishna, you are fairly young, you probably don't know, but HP Labs was an absolutely phenomenal organization, one of these very, very prestigious R&D central research organizations. I mean, at the level of sort of Bell Labs. When I joined, it was sort of Bell Labs, IBM Research, Microsoft Research, and HP Labs. That's it. And GE Research. Those were the main research labs in the world, right? And the opportunity to lead a fantastic, prestigious central research lab of a $120 billion computer company, the largest computer company in the world. It was bigger than IBM at the time, right? Was absolutely phenomenal. And so I did that for 5 years, had a great run working with the brightest sort of engineers and scientists at HP Labs. And then I had a chance to but at HP Labs, I used to report to the group CTO at HP. And then I had a chance to become the group CTO at ABB. So I transitioned to be CTO at ABB, then I became CTO at Schneider Electric, and now I have become CTO at Ansys. So in the last 15 years, in large companies that I kind of mentioned, ABB, Schneider, HP, Ansys, and so on, I have seen how innovation gets done in large companies, right? Where it's not a startup focuses on a particular product, right? And so you're trying to very narrow, very focused. Here is a product. The teams are building the product, selling it to customers, and so on. But it's one product. Maybe a startup will have a second product. But in a large company like HP or ABB or Schneider or Ansys, right? You have 50, 60 products, right? And so the question is, how do you, it's a portfolio of R&D, right? As Ansys, at CTO at Ansys, I'm responsible for taking a look at all 50 products and saying, this product, what are the features that are needed, right? How much R&D should we invest in this product? Here is the other product. Should I be investing more R&D in this or not, right? It's a portfolio approach, and how do you choose those things? And in that setting, you have 50 products. Where is the 51st product going to come, right? How do you innovate? So that is an absolutely fascinating thing, and I've learned so much in my career. But I've essentially sort of now put it all together in writing a book called Innovation Factory, whose sort of title is Innovation Factory: How Large Companies such as Ansys, HP, Schneider, ABB, etc., can pursue what I call Horizon 3 innovation, long-term disruptive innovation in the 21st century by better partnering with startups and academia. I mean, so that's my life's journey. I'm really passionate about innovation. But of course, from a research perspective, I have done a lot of work on parallel computing, on EDA algorithms, and so on, electronic design automation algorithms when I was at Illinois and Northwestern and so on. And so I find myself at the end of my career being CTO of a company, which has allowed me to go back to my roots on the research that I did 30 years ago.
Interesting. There's so much I want to dive into the innovation culture and much of your journey. But before that, I'm super tempted to ask. You graduated in 1981 from Kharagpur, and then you got your master's in 82 and got your PhD in 84. And then by 1985, you were already an assistant prof. So how did you manage to complete your PhD in 3 years and get a faculty position the very next year? That seems like a dream run for most people today.
It is, but I will tell you, a lot of it is luck, right? And so partly it is perseverance, but a lot of it is luck. When you are pursuing a PhD, right, you have to have a fantastic research advisor. I had that in Professor Jacob Abraham, who is still my absolute mentor. I'm still in contact with him for the last 30, 35 years. So having a great PhD advisor absolutely helps. And I know you are pursuing your graduate studies at Rice University. So one of the things I write about in my chapter 2 in my book is how innovation happens in academia. And I mean, there are these professors who have graduate students who do sort of the research work with them, right? And the graduate students, you need to be funded, right? I mean, you are coming from India, right? You have to get some from a financial aid. So there is one type where you get no financial aid. You land up in the US and you're pursuing your PhD or master's, and you have to take a second job on the side, right? You may be working in restaurants, you may be doing stuff, etc., right? And so you're working like 20 hours a week on something completely unrelated to your work, right? Then you're doing 20 hours of coursework and then trying to do a PhD. It is very hard, right? So then the second thing is you get some kind of a financial aid from the university, right? I'm sure when you went to RISE, you probably got some financial aid, right? There's sort of different types of financial aid. One is you get a teaching assistantship where the professor is teaching a class and you are assisting that professor in grading the students and so on. That is 20 hours of work, right? Again, that is unrelated to your research, right? And so now you're taking your classes, which is 20 hours, and you are grading and helping doing TA. Again, it's very hard to make progress towards your PhD. The third form is to get a research assistantship. And essentially, your professor has got a funded project from the National Science Foundation or from DARPA, whatever, right? But then that limits. So you're sort of, yes, you can work for the professor, but you are limited in the type of research that you can do, right? I mean, because that R&D project is related to the XYZ, right? I'm just saying you're a mechanical engineer, right? Related to CFD. So you have to do work in the PhD on CFD, whether you like it or not. You cannot do structural and so on, right? So that also limits it.
So you kind of basically just summarized the 3 reasons why I dropped out of a PhD program. And as a matter of fact, for most people, their PhD advisors turn out to become their nightmares. Unlike you, who seem to have been lucky.
So I'll tell you. So I started as a research assistant for Professor Abra, right? But very soon, it became obvious that the particular thing that is a part of the research assistant is not I did my master's on that topic, but I wanted to do something different, right? Absolutely unrestricted. And so that is what I'm saying. The last form of aid is a fellowship.
Yeah.
So I was fortunate in my second year to get an IBM fellowship, right? And that fellowship, and there's IBM fellowships, all kinds of fellowships that you can get. It is unrestricted. You can do work on any topic you want to. And you're not, so you essentially are getting paid for just doing the PhD and so on. So I was fortunate to have received an IBM fellowship during my entire time of the PhD. I switched my topic from what I was doing for a master's to a PhD on a topic called algorithm-based fault tolerance, which was absolutely exciting in my time, right? But that plus so when you're pursuing a PhD, Krishna, right? I mean, a PhD is not something like building a house, right? It's like okay, I'm a stone layer, right? Brick. I have in a particular day you can lay 100 bricks, and you have to. The house has 1,000 bricks, and therefore it'll take you 10 days. That's not how a PhD works. In a PhD, you pick a particular topic, you do some research, and it doesn't work. You pick another topic, and doesn't work, right? And you're trying to publish a paper, it gets rejected, right? So that the purpose of a PhD is to go fundamentally deep in some area, right? And you're the expert, right? And it is not the specific PhD outcome that is important, is the process of learning how to do independent research. And what I learned in my PhD with the support of my professor, Abraham, was I learned to do this well. It's something really deep, something innovative that the world didn't know, right? That got published in a variety of journals and conferences. But I was able to get to that point fast. And that was the luck factor where I pursued some direction and I was fortunate. I pursued a second topic and it was success, right? In a PhD, you need to sort of do 3 or 4 different sort of subtopics, all related. And all of that sort of clicked. I was able to get all the right sort of publications and so on. And which is why when I graduated in 3 years, you were right. I mean, this is a slightly accelerated pace for a master's and PhD in 3 years. I received offers from sort of more than 6 groups at IBM Research, 7 groups at Bell Labs, and more than a dozen universities. So part of it is luck, and part of it is I was at the right place at the right time.
Very interesting. And one more interesting point that you brought about here is that you chose academia initially because you thought it gave you the freedom to pursue the kind of research that you want to. That being said, don't you also think that once you, let's say, take up a faculty position, you are constrained by the institutions and that are funding you and the problem statements that they are funding you for?
Absolutely. So, I mean, let me kind of tell you, right? So you think that in academia, you can pursue anything, right? But the reality is to pursue your research, I mean, unless you are doing absolutely theoretical computer science, where you can do the work completely on your own without graduate students, right? So, but if you need to work with a team of graduate students, I mean, during my 22 years, I had a research group of about a dozen students at a time, right? 12 graduate students. Each graduate student, right? To support that graduate student, you need like about $100,000 with full overhead, right? Yeah. So $100,000 times the 12 students is $1.2 million per year. Now it's not easy to get that kind of funding, right? When you so essentially at a given time, I was writing like I had to get 3 or 4 successful projects funded, right? And it's a constant run for here is a proposal, you write the proposal and you get funding and so, right? Now, suppose you're a professor in, say, computer engineering, right? You cannot write an astrophysics proposal just because you're interested. You read a fantastic, you watch a show on television about the universe, about James Webb telescope, right? So, I want to do astrophysics. I mean, this astronomy. I mean, and you're doing computer engineering. If you submit a proposal on that, right, to the National Science Foundation, they just say poo-poo, right? You have no credibility in that area, right? So it's very hard for an academic to actually write a proposal on a new topic, right, and get funded, right? So in a way, sort of in academia, I mean, your research thing is your PhD. So you did research in algorithm-based fault tolerance or whatever, right? So if you write a publication, a proposal on something totally different, you will not get funded. So in a way, it constrains what you did in your PhD and what previous work you did, constrains the proposal you write and so on. So that is kind of, it's a vicious...
And it snowballs, yeah.
It snowballs, right? So that is the sort of the challenge. But I was fortunate. So again, as I said, I mean, there are strategies that you can use in academia, right? So you get funded projects, then you try to get things, right? So you get unrestricted grants from companies, right? Which is what I did. I got money from IBM. I got an IBM Young Faculty Investigator, right? Once you get that funding, then you can pursue whatever, right? Because so I'm grateful to IBM, right? They funded my graduate fellowship and they funded my young faculty. They had given me an offer to join IBM Research, right? And I did not join, right? But despite that, they funded my young investigator. So I'm absolutely grateful to IBM for all the things, right? But those kinds of unrestricted grants allows you to do new things, right? So I switched to things like parallel algorithms for VLSI CAD, right? I had no credibility in that area, but I could do those things through those other types of activities. And then once you establish a thing, then you can do this. The other thing is having access to graduate students, right? Smart students like you. I mean, it is impossible for a professor in academia, right, to do all that wonderful work without having access to the smart students. So I am from IIT Kharagpur, right? I got lots of the top students from all the IITs, IIT Kharagpur, IIT Kanpur, IIT Madras and Bombay and so on, right? And the top students from China, right, from Tsinghua and so on, and the top students from Turkey, from Istanbul University. So, I mean, that is something that the US universities have, right? Because of the prestige, it attracts people such as you, right, to Rice University. And I was fortunate to have, as I said, 37 absolutely bright, wonderful PhD students in my career who have all gone on to do wonderful things. Some of them are chaired professors at university like Texas A&M. Others are heads of research at IBM. I mean, this is just absolutely fascinated to have that kind of an PhD sort of ecosystem that I have. So that, I mean, innovation in academia. So now let me kind of bring it down to the key learning that I found, right? That the basic research in the world, the absolutely outstanding Horizon 3 innovations, right, is actually done in academia, right? You look at the COVID vaccine, right? So the basic research is done in academia, but you need the people who do the research is the professors guiding the research, but it's actually the graduate students, right? So unless you have fantastic graduate students, you cannot do the research, right? But then you need the funding to do the research, and the funding is from National Science Foundation or NASA or Department of DARPA, etc. Right? Yeah. So you need funding, you need the students, and you need the absolute top-notch professors to do this, right? So when the average person who is listening to your podcast is saying, "Oh, you're in academia, you teach," right? No, I mean, I teach only a third of the stuff that I do, right? The main thing in a research university like Rice, like Northwestern, like University of Illinois, MIT, Stanford, is the research that you do. So you learn new things, right? And then you teach the students about the new thing that you learn, right? Anybody in a 4-year college, right, a community college, can read from a book, right? Here is a book. What is written in the book? I can teach it, right? That is the standard sort of 4-year community college teacher. The professor at a research university is the absolute deepest expert, right, in the field. And my field was parallel algorithms for VLSI, for electronic design automation. Nobody in the world knew more about that topic than I, right? Yeah. So the graduate students come to me and they're getting fantastic. I wrote a book on that topic. So I'm supposed to be the expert in that topic, right? That's why the students go to those research universities. So the thing is, I was doing research in parallel algorithms for CAD, all those publications, but no EDA company was actually using those algorithms, right? So I went to Cadence and Synopsys and so on, and nobody used those things. So that is kind of why I got sort of fed up. I said, this is not right. So you have to do something, right? So do the tech transfer. So the point about innovation in academia is just absolutely innovative things do happen in academia, but they don't do product, right? They are doing the knowledge. And so I write in my book, right? Len Kleinrock at UCLA, right, in sort of is attributed to inventing the internet, right? I mean, all he did was sort of show how this sort of networking and what connectivity actually works, right? Or Jennifer Doudna at Berkeley sort of invented this the whole mRNA vaccine technology, right? She did not invent the vaccine, right? The vaccine was invented by BioNTech and Moderna, based on 25 years of research that Jennifer Doudna did, right? And she got the Nobel Prize in chemistry for it, right? And I talk about Irving Jacobs at UC San Diego, who invented sort of wireless communication, etc., that became sort of Qualcomm's technology. So the point being that academia, universities do phenomenal fundamental research, but they stop at their publications. They don't do a program. There is a gap. And that is where you need to go to a startup, right? Which is why I went to my startup. I did the 2 startups, right? But not, I mean, you look at the 1,000 professors in the world, right? Maybe 5 of the 1,000 will go to the journey that I went, right? Because I mean, people in academia, they love academia, they're publishing and so on. Not all of them want to go through the whole process of pitching to VCs and getting told no, pitching to VCs and getting, I mean, it is hard, right? Getting those kind of failure things is not easy. So you have to have a particular kind of a thing. And then, of course, you have to adapt. You think you are doing this, and then sort of doing it from a customer perspective and building a product is quite different from writing a peer-reviewed journal and so on. So that is kind of anyway. So let me pause here to see if you have any questions on academia before
I do. So the thing is, like I mentioned, there are two constraints why academic work gets stopped at the publication level, right? And one of those reasons is funding, and the fact that funding today is provided by just a few organizations, be it the NSF, DARPA, or Air Force Research Lab, and some of these organizations, and in some cases, some research labs like IBM or Bell Labs. Now, the question to ask is, why is it that private companies or startups or big corporations are not willing to actively collaborate with academicians to either license their IP or do some tech transfer, so that much of the innovation that gets done in the lab can go to the market faster? Because typically in academia, we see that there's a very long gestation period, sometimes even close to 2 to 3 decades. Like you mentioned, how the vaccine for COVID, it's a culmination of 25 years of research of Dudna. If you take it, let's say lithium-ion batteries, the work was done back in 90s, and it was only in mid-2010s that it really came to the market. So what do you think can be fixed to sort of reduce this gestation period and convert this, allow for this transfer to happen faster?
That's a great question. And part of it is sort of the way the funding models in universities are set up, right? In the university, they're supposed to do basic research, right? So funding agencies like the department, DOD, DARPA, or NSF, etc., they all fund fundamental research, right? But there is a gap from that research prototype that was demonstrated in a lab to a product, right? It takes sort of 2 to 5 more years to productize something, right? Unfortunately, there is no funding available today to fund what is called translational research, right? In the healthcare area, there are things called basic research, and then there's translational research to actually convert that into sort of clinical trials and all that. In the rest of engineering, there is no such thing as translation research. This is actually a fundamental problem that happens in the industry. Then you go to the VCs, right, who fund startups, right? They don't want to fund R&D, right? So they fund a startup where an entrepreneur like you, right? You say, oh, hey, I have built this thing, right? And you have to do this on your own, right? So the VC will not fund R&D. They will fund something that you have prototype, right? So basically there is a gap in this thing, right? And so I am serving on the National Academy of Engineering's, there's a very important steering committee that has been formed, right? To kind of fix these things and so on. And that the NAE combined with the National Science Foundation, they have recommended, right, to change the way NSF funds their stuff. So this year, under the Joe Biden's presidency, right, NSF just received a funding, right, to create a new directorate for TIPS, which is called Translation and Innovation Partnership, right, to fund literally the thing that we are talking about, right? So they will take this basic research and fund more in the innovation, but in partnership with startups, exactly along the lines that we're talking, right? But unfortunately, I mean, it has not been funded at the level that you want, but at least there is understanding at the NSF that this is a problem, this is a gap, right? And so they are funding this kind of this translational research in sciences and engineering, right? To carry it for a little more, right? And then the VCs would pick up the funding and so on, right?
But even if you made...
So let me, so the other thing, right? So when you are at a university as an academic, right? I was motivated, the metrics that we have in academia, they encourage more publications, right? People do what you see the metrics, right? If you get promotion, right, based on, hey, why will I get, I have to get a tenure, right? You need to have, say, 10, 12 publications in journals, right? So then as a professor, you're motivated to only do the publications journals, right? They don't give a current university administration, they don't care whether you have started a company or not, whether you have done patents or not, right? License. So they don't do this. People do what they are motivated to do through the metrics that will promote themselves. So in academia, it is all about, well, we'll value the teaching. So you do some good teaching and you funded, do research. How many PhDs have you graduated? How many publications have you got, right? Not whether you have transferred something to academia, to a company or not, have you licensed, right? So very few professors actually try to patent their work, right? So they're doing all the publications, but very few patent their work. I did 6-7 patents because I was interested in doing my startup, AccelChip and BINACHIP. And in order to do the startup, right, I needed to show my VCs that I have some kind of a patent around it, right? And essentially, AccelChip licensed the technology from Northwestern University as an exclusive license, right? In exchange, sort of the university got some sort of equity ownership, right? And some percentage of the royalty, right? Of the income that will be generated through AccelChip stuff, right? So that is a very, very complicated process. And most universities have their sort of office of vice president of research, right? Of IP, right? That oftentimes put a very high bar on the licensing, right? Because they look at certain universities like Wisconsin that made a ton of money on the patent for pasteurization of milk, right? I mean, you go to the Wisconsin Research Foundation, Reward Foundation, I mean, and I write about it in my book, right? I mean, they are making a ton of money, right? So essentially, Wisconsin got rich by that patent on the pasteurization, right? So every licensing person in a university say, oh my God, I'm going to jack up the royalty, right? So it becomes so difficult for a startup to this, it's not worth it, right? So let me try and so I think the universities are trying to protect their IP, right, and getting so much out of it, right, that oftentimes it's not worth, right? Now, obviously, there's things like the Bayh-Dole Act that I write about in my book, right, which says, yes, obviously, universities need to protect their IP because they have done the research and so on, right, funded by DoD and so on, right? So there is a lot of motivation from NSF and DoD to show, yes, this is transferring to the startups and so on. But there are these little barriers, right? The universities try to be super rich with something, and they don't realize that it actually takes a lot of work for a startup, right, to convert that IP into something that will be productized, right? So it is really not the patent, but it is a process of how do you take that innovation and build a real product out of it? Because that one particular publication will not be the product. The product will be a set of, like, you think of it as you have a pearl, right? An individual innovation is a pearl, but you're trying to build a necklace, right? So to make that necklace is not just finding that one pearl. You have to find 10, 20 pearls and you string it together in the necklace. And the necklace, you may build that first necklace and the customers will not like the necklace. They're, oh no, I don't want it with 10 pearls. I want it with 15 pearls. I want with some with white and blue pearls, right? So that's the process of the product market fit that a startup has to do. And if you are getting stuck on that one particular pearl and you get a lot of license to the university, there are things that are sort of barriers in the process.
Got it. But one point worth noting here is what you mentioned, that universities typically own a stake in the IP rights of whatever the patent is being filed or being licensed, which basically means that it's in the best interest of the university that a lot of this is commercialized. Despite that, why is there a very strong emphasis on just publications? So the reason I ask this question is, okay, for sure there is a funding crunch and much of these constraints that prevent, let's say, an academic from going ahead and trying to transfer their research to the market. But that being said, do you also think there is a fundamental inertia within academics to not think beyond publications, and it need not necessarily be because of the incentives? It's at some level, do you think it's also to do with personal motivation?
It has to do with incentives. I'll tell you, Krishna, it has to do with incentives and the people in the promotions committee, in the dean's office that are reviewing your promotion, right? See, if the rest of the people that are evaluating you are all part of the culture of publications, right? And here is this brand new faculty who has done an absolutely amazing work in a startup, right? And he has really made an impact, right? When I did my startup, right, it was a big impact. But fortunately, I did my startup after I was a full professor and so on. So I didn't have to go through all this nonsense. But as an assistant professor, right, you do a startup, right, and you're doing the startup, and in the process, you're not getting as many publications out of it, right? And so you don't have as many PhD students and so on. and a bunch of committee members who are evaluating your tenure, okay, says, Prith doesn't have enough publication, right? And because people, we are all humans, right? We think, oh, I am great, I'm a full professor, tenure professor, right? And you, Krishna, you are not like me, and therefore I will not bring you to my club, right? So it is incentives and the way people have been sort of set up and so on. And so what NSF is trying to do is the TIP program trying to change the funding model. There are very, very sort of forward-looking universities like Stanford, for example, right? At Stanford, you can actually get tenure with just a single publication, but as long as you have real impact, right? There's a sort of very prestigious organization called the National Academy of Engineering, right? Yeah. They don't only look at publication, they look at the impact. Have you actually had impact with the research you have done? Had this impact changed the lives and so on? So there are things that are being sort of changing, right, in order to do this, right? Because there's this publication game. You can get zillions and zillions of publications with not as much impact, right? But what you have to do is to change the whole culture, right, in research universities to make sure that this kind of innovation is also valued. I'm not saying that all they should do is to only look at startups and licensing, right? But they should look at a variety of times. Some professors will do more publications and so on. Others will do startups and so on. And both types of people are important, right? And both kinds of people need to be promoted.
So that is
the change in places like Stanford and so on. And in some of the universities that are moving up in rankings, like UC San Diego and so on, if you look at some of the schools, right, there are schools and universities that are actually moving up in rankings because they're taking that kind of an approach to driving innovation.
Got it. But how do you create that culture? How do you bring about a systemic reform that allows for both of these to sort of co-live with one another?
It starts with the leadership, I will tell you. And this is why I was a department head at Northwestern, right, for a while, right? During my years as department at Northwestern, I actually put in changes, right? When I was promoting people, right, in my department, right, to give them tenure, I actually put in newer metrics to advance those kind of people. When I was dean of engineering, right, I was trying to change it. So it actually starts with the leadership, right? So and so universities are recruiting leaders, right, who will, I mean, for the tenureship, it is actually the dean. That is the dean of engineering is the most influential person, right? How he sets the tone, right? So it all starts with the culture and the tone and the direction set by the dean. So you have certain deans that are part of the new way of innovation and so on, and they're being creative. Other deans are part of the old way of doing things. Both are okay, but it actually starts with the dean. So oftentimes what happens is colleges and universities, right, they change direction under change in the deanship.
This is interesting. I think I've read enough about a similar situation happening with IISc when Satish Dhawan became the dean or director of one of those. He took one of those positions, and that really set IISc on a different momentum altogether for it to be a research.
Directors of IIT Madras, right?
Yeah.
Ashok Jhunjhunwala, right? I mean, apparently he has done some, I have heard, right? I mean, he is responsible. I mean, there are IITs and their directors and so on, but certain directors have done absolutely amazing stuff, which is why a whole bunch of new sort of companies and so on came out of IIT Madras and IIT Bombay and so on, right? So yes, leadership does matter.
Okay. So you were saying that it all begins with the leadership. So then the thing to ask is, do you think getting in people who've been industry veterans and people who've had successful stints in startups and industries into these leadership positions is going to make any difference? Or do you think it's important that, let's say, a dean or director has to be an academic?
You cannot say, I mean, it clearly helped for me personally, right? Having that startup experience, right? I mean, I think that is what made it attractive to the University of Illinois, right, when they hired a dean, right? Because I know that the provost at the time, Michael Tanner, he actually said, Prith, we are hiring you because you have that unique experience, the combination of academia, right, having the 350 publications, and you have done startups, right, which is why they were attracted to the hiring me. But look, there have been cases where universities have hired dean purely from the outside, right? From an industry setting, right? With no academic experience and they have been disasters, right? Because the culture of a company, again, hopefully during the rest of the podcast, we'll go into how companies do innovation and so on, right? I mean, the people that go up in IBM or HP or Ansys or so on, right? I mean, and they have zero idea of how innovation or things happen in academia, right? So it can actually be a disaster when you hire a person from the outside with zero academic experience, can completely mess up a college or a university, right? You have to have the right leadership to really understand and respect the past and be in a position to transform into the future. I mean, many people have asked me, how do you define leadership? It is the role of a leader is to sort of establish a vision for the organization, right? What does the organization stand for? What should be the vision and so on? But then you have to not only just, oh, here is the vision and here's Prith's vision and you guys should follow it, right? No, you have to actually take a lot. I mean, you have to really motivate people, right? To rally their troops around the vision and constantly make sure that people are contributing to the vision. So it is a hard step. And I've gone through sort of strategic planning processes at Northwestern. I've gone through strategic planning processes at University of Illinois at Chicago, right? And there's just massive efforts. It requires a lot of working with the faculty to make sure that they do the kind of things that they will do. Because if it's just coming from the top, here's the dean saying this, it is not going to happen, right? So, and that is part of the leadership that I'm talking about here. The leader has to have a vision that this is what we are going to do, right? And then rally the entire organization, right? That will sort of be part of the vision and so on, right? And if that vision, I mean, if they try certain things and it's not working, the leader needs to say, you know what? We tried this, it's not working. Let's talk to the organization to say how we can pivot and adapt and continuously change the direction, right? Not every day, but at the right times, right? So that is what a good leader is.
True, but since you mentioned this, do you think one major difference between, let's say, industry and academia is the fact that, let's say, if you're a leader in an academic setting, let's say you're the dean or the vice provost or one of those, you might have a certain vision, and you, like you mentioned, you have to first get the entire university or the entire organization on board with your vision. As opposed to, let's say, in a company, the very fact that a person has joined this company already sets the base mark that they are already aligned with the vision, and they sort of just blindly abide by what you ask them to do.
You're absolutely right. Let me kind of tell you that the difference between academia and large companies is, in a company, if you are the vice president and the vice president says certain things, the employees are supposed to follow the instructions or leave, right? You cannot just openly say, hey, I don't like your stuff and so, right? So that there is a certain amount of discipline that goes with working in a company. In academia, the reason people have tenure, right? Again, that was designed beautifully many years ago, right? 30, 40 years ago, right? In the US, is to make sure that a person in academia can actually speak freely without getting fired, right? So you cannot fire a tenured professor, right? So in academia, what I learned in being a dean is you cannot say, hey, I'm the dean. You have to, you, Krishna, you're a professor, you have to follow my instruction, right? You have to get people on board knowing fully that they are tenured professors, right? And make the case that it is in their best interest, right? The question is, do you, Professor Krishna, right? Do you want to be part of a prestigious university with high rankings? And there is, and no professor will say, no, I want my rankings to go down, right? So they want to be a top university, right? So let me see, if you want to be a top university, how does it happen, right? You have to have impact. Do you want to have impact, or do you want to just do work in public? So you have to you have to sort of start with sort of something that everybody can agree on, right? And just then get people all aligned, right, along the things. So you cannot just say, oh, from tomorrow, I want you all writing sort of startup proposal, right? Boom. And why are you doing this, right? You have to start from the objective, the mission, vision, and then get everybody aligned with the strategy and the tactics and so on, which is sort of what I did when I was the Dean of Engineering at the University of Illinois, Chicago. So, I mean, so it is a complicated thing, right? It is not easy to transform a university thing where you basically have tenure, right? And that's a good thing. Having tenure is a good thing because you want university professors, right, to say, right, even though I'm just saying, for example, right, there may be certain companies who may say, I'm just making a ridiculous example. Suppose this cell phone is bad because the radiation is bad for your brain, right? And there's studies that have said cell phones generate electromagnetic things, it's bad for your brain, you can have brain cancer. Suppose there is a thing like this, right? Now, the cell phone companies would absolutely say, hell no, right? Because that is bad for their business. Now, right. I am a professor. I will do fundamental research, and I will say, if my research says this radiation is bad for my brain, even though my dean and the president says they're getting money, I'm just saying, from say Ericsson and Nokia and Apple and Samsung, right? Suppose the university gets a ton of money from the companies, right? And this professor about to publish this paper. In a company, the company will say, we will not publish that paper.
Right.
But in academia, the professor has the right to publish it no matter what, right? And he should not be sort of
influenced by these,
influenced by these corporate things. And that is the fundamental reason why you have tenure.
Right.
You can say things about, I'm just saying, democracy is good or dictatorship. So I'm just saying, right? Dictatorship is great. I'm just working in a thing, right? I'm a political science professor. I say dictatorship is fantastic for this thing, right? And in a company, you say, are you crazy? We'll fire you. No.
Right.
Or you can, I'm giving ridiculous examples.
Yeah.
Today, as you know, right, is Auschwitz, right? It's this memorial of the Holocaust, right? So some people say the Holocaust is fake. I'm a professor in political science. I write a fundamental paper saying Holocaust is fake, and this is why, right? As a professor, I can publish that work and not get fired for it.
Yeah.
As a company person, you cannot. So my point is there is good things in being independent, in tenure, but in that setting, right, being a leader, the department head or a dean or a president, right, you have to work with the professors and get them aligned, right? A whole bunch of tenure professors all aligned towards this vision of the changing from pure publications to let's just do some startups and patenting. That is an absolutely fascinating journey.
Very interesting. This is possibly the most optimistic explanation I've ever heard in favor of tenure. Because tenure is almost seen like that reservation concept, which sort of just spoils people, or at least so in the perception of graduate students predominantly.
I know, but I'll tell you, fundamentally, it is good because if you believe in certain things, right? I mean, as a professor, you are supposed to absolutely believe in whatever and you make your case, right? I mean, like this week in the US, there's a big sort of debate going on, and I'm going off topic, right? But I heard this on NPR yesterday, so I'll just share it with you, right? So the college board in the US is saying approving certain things called for AP credit, right? Advanced placement credit for high school students, right? To learn about Black history, African history, right? Now, it's a very controversial thing, right? I mean, this whole slavery and so on and so forth. So there is a way that history is taught in the normal courses in the US, right? In high schools. Here is this advanced thing, which is putting a alternative point of view, right? You know what? This is actually not a good thing. And it was a fascinating article yesterday, right? Now, and these are being done, right, by sort of people who are tenure and so, right? And here is sort of the top level government saying no, like the Florida government is saying no, we'll ban these courses. But my point is, and they were interviewing some students, they said, I'm just so glad that I'm taking this class because I'm getting an alternative perspective of US history, right? This is why tenure is important.
Right. So
anyway, I went off track.
No, that's completely all right. And it's an interesting perspective, right? So when we say that tenure actually gives you more authority to go out of your way and to defy all odds and still stand by something that you that might not be agreed upon by most people. And that is pretty much what is needed when we speak of, let's say, innovation. And by and large, academics are super smart people. So these are people who are thinkers and are builders. But why do you think, okay, besides the incentives part and all of those, what do you think is fundamentally different from your experience in the cultures of, let's say, industry versus academia that sort of slows down innovation in academia?
I did not say slow down innovation. I sort of, if you now, let me say, in my book, I define innovation as something. So let me define innovation. Innovation is something new that the world didn't know, right? That actually has value. It can be economic value or societal value. That is what innovation is, right? So a lot of innovation actually, and so then I kind of talk about the concept of, so let me go back, right? Talk about the concept of Horizon 1, Horizon 2, Horizon 3 innovation. Horizon 1 innovation is you have a certain product, right? You have this cell phone, right? Which has, I don't know, 1 megapixels and this range and whatever, right? And in the next version of iPhone 15, Apple will do XYZ features. That is incremental innovation, right? That's Horizon 1 innovation. Horizon 2 innovation is adjacency. I have a phone that works with 110 volt and whatever thing and some frequency CDMA in the US, and I'm trying to bring a new phone to, say, Africa, right? With different voltages, different wireless spectrums and so on. It's still a phone, but it's with different change. Or you have a transformer in US from ABB, and you're trying to go to a transformer in India with 220 volts. That is Horizon 2 innovation, right? Horizon 3 is I am ABB, I make transformers and switchgear, I want to move into software. That is disruptive. And my point that I write in my book is Horizon 3 innovation is the hardest. Companies do a great job in the Horizon 1. They know their existing products, they're selling their products to customers and so on. They say, hey, the customers want these features. I have a competitor, right? I'm at ABB. Here is my competition. Siemens is doing this stuff, or GE is doing this. I make this thing that they made, right? And so, and as it turns out, that 70-80% of the R&D budget in a large company is actually Horizon 1 innovation. That companies do super well. Nobody can do better because they have perfected the art, right? How much investment should I put in? What is the timeline, gated roles, etc. So I will sort of talk about it. But the disruptive innovation, right? You want to come up with this mRNA kind of vaccine, right? That is not something that will happen in Pfizer, right? Out of the blue, right? That's the incremental innovation will not get you to that mRNA vaccine, right? That is where academia comes in. So academia is actually the best place to do a truly disruptive innovation, right? Because they don't care about any constraints or so on. They're saying, here is a problem, here is a way to kind of solve it, right? So you should not say that academia doesn't do. Academia does Horizon 3 innovation, but it doesn't go all the way into a product. That is sort of what I talk about. So then I say in my book that startups are actually uniquely positioned to do the Horizon 3 disruptive innovation. Right? So because they take a thing like say Moderna, right? They pick this particular topic of mRNA and they made a product, right? And so, right? Or BioNTech, they did, and basically they did independent, right? And so then, but in a large company, it is hard to do this kind of thing. So the point that I'm saying is startups do fantastic in Horizon 3 innovation, but about a particular product. Universities also do great with Horizon 3 innovation, but they stop with the publication. They don't go all the way to a product. That's the challenge. And in large companies, they are all doing sort of Horizon 1 innovation well and 2, but they don't do the 3, right? So what I essentially say in my book is that for a large company to do Horizon 3 innovation, they need to partner with startups. Look at Pfizer, BioNTech, right? BioNTech did the mRNA vaccine, right? But they did not have the scale to bring it to market and get through all the FDA protocols and so on. That machine is set for Pfizer. Pfizer knows how to bring a product to market and get through all these FDA protocols and so on, right? BioNTech didn't have it. BioNTech made the vaccine. So by the partnership between BioNTech and Pfizer, you do amazing things. You can actually do this disruptive innovation about the COVID with our mRNA and you bringing it to market with the scale, right? So that is essentially what what I say in my book is large companies need to partner with academia, fund people. I mean, that's why sort of IBM funded work at University of Illinois, right? The IBM Graduate Fellowship, all those kind of stuff that the companies do is a good thing in academia, partnering with the universities, because that is how they recruit their graduate students into their stuff, and absolutely innovative technologies coming through this thing through that. But then those R&D projects are not necessarily fully baked, right? And so it takes a lot more work in a company to take their product the R&D project from a university into a product, but that is where they should constantly be looking, right? If companies only restrict to R&D within their own organization, they will absolutely miss the boat. So open innovation is a term that I use in my book. It is not coined by me, it is coined by very famous professor Henry Chisborough at Berkeley, who I interview in chapter 9 in my book. That is the key to disruptive innovation in large companies.
Interesting. I completely agree with what you say that industries do Horizon 1 and academia is amazing at Horizon 3. But I want to dive a bit deeper into startups, because startups are a species that is always facing crunch of capital, is facing crunch of resources, and is always racing against time because they are on a survival mission. And how do you say that these are people who are positioned to nail Horizon 3 innovation, because Horizon 3 typically requires more time and more resources?
So that is a great question. So let me give you the challenge in a large company, and then I'll tell you why a startup can do it, right?
Okay.
So when Apple had the iPod, you're very young, you probably have not used the iPod, right?
For music. I've used an iPod, but very young, yeah.
And then people knew that, hey, and when Apple said, hey, I'm going to do the iPhone, right? The natural reaction within large companies, oh my God, if I do the iPhone, which will have all the music and so on, that will kill my iPod business. Mm-hmm. Large companies oftentimes know about these new technologies, but they don't embrace it because they have a cash generating machine in the older business. Mm-hmm. People say Kodak is stupid, right? They still remain in analog printing and so on. They are not stupid. They actually knew about digital printing. They had all their stuff in the Kodak labs. I have actually visited the Kodak labs in Rochester, right? They knew everything, but they did not embrace it because of their cash cow business in the analog printing that they wanted to keep on. Same thing happened with Blockbuster, right? Blockbuster is this large organization, right, that used to go to Blockbuster to rent a VHS cassette and so on, right? That was the business model, right? And then Netflix killed it by saying, hey, you don't have to go to whatever. You can just ask it. I will mail you the VHS. And then Netflix said, forget the mailing. You just log in. I'll do the streaming.
Right.
So that is what killed Blockbuster. Don't think that Blockbuster did not know that this could be done, but it would be bad for their existing business, right? Same thing happened with Nokia. Nokia knew about digital sort of cell phones and so on. But Motorola knew about digital things, but Nokia came in and did the digital phones and so on, right? So that's why Motorola died. So it's not these large companies are stupid. They know it, but this is sort of the problem, the thing that I talk about in my book on a large company as CTO, right? I'm looking at portfolio of projects, a portfolio of products and so on, right? And I kind of put it in a 4-quadrant thing, right? Where a product is growing in revenue, right? Growing or not, and is profitable or not. It's a quadrant, right? So products that are highly profitable and growing are the top right of the thing, and absolutely needs to be funded, right? So that is an obvious thing. But there are products that are profitable, generating cash, but they are not growing in revenue. What do you do with a product like that, right? iPod versus iPhone, right? So then there's a product like the iPhone, which today in 2000
growing but low revenue.
Low revenue and no profit, right? It's losing money.
Right.
Fund that or not, right? Well, you have to figure that out, right? That's the portfolio thing, right? And so large companies seeing all these things, they sometimes make the wrong decision because they're trying to maintain their cash cow business, right? Too long, and they don't fund this new project, disruptive product. A startup has nothing to lose. You look at Salesforce, right? Salesforce is about CRM on the cloud, right? Oracle was doing CRM on-premise. Don't think Larry Ellison did not know that cloud is coming. But it's bad business, right? Because Oracle is selling their CRM, right, on-premise, on sort of paid-up licenses, millions of dollars that Oracle is making, right? They see the cloud, they say, oops, no, I will not do it. Salesforce had
disrupted that.
Right? They were zero. They don't care, right? This is just
Right.
they're starting from zero and they can grow the cloud business. That's how CM on the cloud happened, right? That's how Salesforce got started, right? HR on the cloud, right? Sort of Workday. That is HR on the cloud. Again, Oracle had the HR, right? On premise, but Workday came in and disrupted it. NetSuite, right? ERP on the cloud. SAP had on the premises. So don't think SAP didn't want the cloud, but they did not want the cloud business, which is disruptive, is a sort of SaaS as use as you need it and so on. It is bad because it will hurt their current business, right? Which is why large companies are not successful with Horizon 3 innovation, right? On the cloud, for example. You have a startup like Workday, NetSuite, or Salesforce coming from zero. They have nothing to lose, and they do it. And where are these people coming from? From Oracle, right? So a person who is a leader in the company, right? You say, I want to do this on the cloud. The manager said, no, this is bad for the business.
He's going to quit and start out.
At that point, he quits and starts the startup.
Yeah, that's also the story with WebEx and Zoom.
Absolutely, and WebEx and Zoom, right? So Eric Yuan, right, who I know personally, right? He pitched it at WebEx and so on. He said, this is not going to work. So he started Zoom.
Yeah.
Most startups are started by in fact, Ansys, the company I work for, started by John Swanson. John Swanson had this idea. He was working at Westinghouse Corporation, right? They were building nuclear reactors. And he says, in order to build a better nuclear reactor, it would be good if I could have a finite element analysis software that would allow me to build a better nuclear reactor. He goes to his manager, says, I want to write a FEM software. And the manager says, absolutely no. So Swanson could have said, okay, fine, sir, I will stay and do whatever you ask me. He quits. He starts Ansys, right?
Yeah.
And who is the first customer? It is Westinghouse. So he goes out, starts it. This is the startup. So the point about the startup is the startup founder has nothing to lose. He's doing a disruptive innovation. The world didn't know about finite element software, right?
Yeah.
John started it and he made it an immensely successful company. We are now a $2 billion company because of John Swanson, right? It came from zero, right? It's a disruptive stuff that happened. And that is sort of the message that I'm making in my book called Innovation Factory.
Interesting. And since you mentioned a lot about this Horizon 3 innovation and big corporations sort of falling back, despite knowing it, they don't, jump onto the wagon. So then I want to ask, with open source platforms like OpenFOAM being in the picture, what do you think is the future of, let's say, Ansys or ComSol or things like these?
So actually, open source has a place in innovation. I mean, I absolutely embrace open source and so on, right? But if you can get a piece of software for free without having to pay for it, right? Obviously, that is disruptive to a company like Ansys, right? That is making money on Fluent.
Right.
The thing that you get with Fluent is all the support and all the bells and whistles and so on, right? And it will sort of work all the time and so on. So your commercial software has to provide added value to what is existing in the open source world, right? You look at Linux, for example, right? I mean, Microsoft was having Windows so all this, you have to pay for the Windows. Here came Linux, open source, right? And Linux politics say, oh, I will just do open source and so on. And so all the CIOs say, oh, I will just get open source. You try to run open source in a large corporation, right? It's hard to maintain and so on. So, you have Red Hat coming in saying, I will take that Linux, but I will provide services for you. So if you have difficulty with installation and so on, you have a place to call, right? With Windows, you could call up Microsoft, hey, this is not working, call up. If you are Linux, you install it on your own, it doesn't work. Your CIO organization has to fix it, right? This is a bug that customer support is something that people want, and which is why they pay Cloud Data or Red Hat or whatever, right? And so that's how this business is coming, right? So as it turns out, right, Ansys acquired a company called LSTC, Livermore Software Technology Corporation, right? So it's a piece of software called Dyna that came out of Livermore, right? So Livermore, Lawrence Livermore Labs, they do research on nuclear bombs and so on, crashing and so on. So here's a bomb that is crashing, what's going to happen? there is a piece of software developed at Livermore Labs called Dyna, right? Done at DOE Labs, so it was open source. So anybody could use that crash testing software. But very few people knew how to actually
use it. Yeah.
So John Hallquist, who was at Livermore Labs, he says, you know what, I'm going to start a company called LSTC, who will take that open source software Dyna, and I will provide stuff, right? So if you are a car company, you take the Dyna software, I'll make you a custom software that will do crash testing and with all the support and so on. So GM and Ford could take that Dyna software and try to do it themselves, or go to John Hallquist, LSTC, and buy his services. So, sometimes people think, oh, open source is good and so on, right? But open source doesn't give you that full
customer support,
right? And LS Dyna became a super successful company based on the open source software. So successful that Ansys bought it in 2019, right? And they are now part of Ansys. So that is sort of the point. I think open source is good, etc. All kinds of innovation happening. But for a customer who are trying to solve that, you have a car you're trying to build with external aerodynamics, or you're trying to build an airplane, right? And you are trying to build an airplane with a target. You are sitting in Airbus or Boeing and trying to build that airplane. You don't want things to have sort of not work, right? With lack of service, which is why open source things like OpenFOAM are not a threat yet, because the value that Fluent provides is a lot more with all the workflows and the HPC and AI/ML capabilities that we are bringing in the Fluent software, right? Which is not part of OpenFOAM.
Very nice. So what I gather from here is basically...
Let me actually tell you another story. So Google has this platform for doing search, right? And the core platform is based on this piece of software called MapReduce. I don't know if you have heard of MapReduce, right? So what Google did is they said, well, there are all these smart professors and graduate students outside. What if we were to open source MapReduce? Let the universities do all kinds of work on MapReduce. So on the form of open source, right? So if you have an open source software that is directly competing with a company's business, right? That is not a good thing for the company.
Right.
Then you have MapReduce, which is part of a core infrastructure for Google and Yahoo. And you open source that part, and people are adding more and more stuff to it, right? And people at Google are added more stuff to MapReduce, and Stanford and CMU students are doing this. That is good for Google because they can take all that innovation
data. Yeah.
Nobody can make a business out of MapReduce, right? The business is ads, right? That search thing is based on ad, but it is based on MapReduce. Right. That is a brilliant strategy on behalf of Google, right? Look at the AI/ML sort of things, the platforms and so on, right? TensorFlow, PyTorch. These are things that were developed again at Google and Facebook and so on. It helps them with their AI search methods, but they open source it. And all these people in academia are adding a lot more stuff to it, and it's feeding the AI work in this company. It's absolutely brilliant. So, I mean, when open source projects are done very smartly by companies, right? It is absolutely brilliant. But obviously, OpenFOAM is sort of a direct, because there is OpenFOAM doing fluid software simulation and there's Fluent doing this. So there is a conflict here, right? But if Ansys did not have a Fluent product, suppose we had a product that is sitting on top of OpenFOAM and doing other stuff, then it would be very well aligned. That open source to the aligned. So that is, so I'm just making that connection to PyTorch, Cafe, right? And TensorFlow, and with MapReduce and so on, and Hadoop, right? And how, if it is part of the core infrastructure, that is good, because the open source world is actually helping the Google business without the professors and graduate students actually realizing it, which is kind of, I mean, if you think about it, right? The Google should pay royalties to all the wonderful people that are adding to their stuff, but right? But that's kind of anyway. But I think that's a brilliant strategy for open sourcing.
But since you mentioned that it's a good idea, let's say for OpenFOAM, for instance, in this context that we're talking about, if OpenFOAM becomes, let's say, the base protocol, and then whatever Ansys is doing or COMSOL is doing are, let's say, modules built over parts of OpenFOAM that make it easier for people to use it. Now, there are two things to consider here, right? One is who is the person using these softwares. So if it's, let's say, someone at Airbus, someone building the Formula racing cars, if it's one of these folks, then they're obviously very proficient people who want access to the best of softwares and have access to end-to-end workflows and all of these. As opposed to, let's say, if you're talking about student community who predominantly use, or in your words, contribute a lot more to the open source world. We do not care as much about the kind of tools that we have, because for us it's a learning curve, and an open source platform allows us to learn more and better. So the kind of proposition which you proposed is, would you say that it's applicable only for enterprise tech? Do you think the only way to make money of the kind of business is if enterprises license this tool or software you're providing for really huge sums of money, and that's the only way to make money?
So actually, it's not entirely true. So let me kind of tell you about where Ansys is headed. So this is sort of along the lines of the future of Ansys, and I will explain to you what we are doing, right? So we at Ansys have embarked on a process of cloudifying all our products, right? I mean, that is not a big deal, right? So yeah, it's running on-premise and it should go on the cloud. So all our core software, like Ansys Mechanical, which is structural software, running on the cloud. Our fluid software, Fluent, running on the cloud. Our electromagnetic software, HFSS, and Maxwell running on the cloud. Our semiconductor software, Red Hawk, running on the cloud. So that is sort of the journey. Now, when you take a piece of software like Fluent, right, there's just a massive monolith of software, right? It has the pre-processing workflow and the meshing and the solvers, and within the solver, like the 10 different solvers and so on. Then you have the post-processing, so you can see the output of some. It's one gigantic $10 million piece of software, right? You put that on the cloud. So what we are saying as part of this, a project called PyAnsys, right? PyAnsys starts with Python interfaces, Python APIs to our Ansys software, right? That's the broad concept. So we're taking large pieces of software like Fluent, and suppose you can break it up into smaller functions, right? Here is the pre-processing part of Fluent, and we just call, I'm just making it a name, pre-prop Fluent, right? Mm-hmm. And I provide you all the Python APIs, API 1, API 2, etc. So, and with these things, you can access the core parts of pre-prop Fluent. Then you have a bunch of APIs around the solvers of Fluent, which is using finite volume methods, you're using this, etc. Then there are all the meshing methods, mosaic meshing or this meshing, and so the meshing methods of Fluent as APIs, the solvers of Fluent as APIs, the post-processing, right, showing it on a 2D screen, 3D screen, etc. as Fluent. And you provide all those as Python APIs. Mm. We have put all those Python APIs in the open source as part of the PyAnsys project, not only for Fluent, but for Mechanical, our MAPDL software, our HFSS software, and so on. So the question is why, right? Because we believe that the value is in what we call democratizing simulation. That simulation can be used not only by these very sophisticated people at Airbus who know how to do external aerodynamics on an airplane, but let's say I want to have a doctor, right, in the healthcare setting, right? I'm about to do a surgery on Prith. Prith has arrhythmia, right? And I need to do a surgery to insert a pacemaker, right? Imagine I could do a simulation model of the heart, right? And imagine in the future that Prith goes into a doctor, he does an MRI scan. From that MRI scan, you can do automatic segmentation of the heart tissues and so on. And it automatically feeds it into LS-DYNA. And LS-DYNA has a way to do sort of the electrophysiology modeling of the electronic signals that are going to the heart 70 times a minute, and the mechanical modeling, which is the muscles contracting, and the blood flowing from the atrium to the ventricle, right, which is fluid modeling. You can do all of that multiphysics modeling in LS-DYNA. Imagine that. Actually, you don't have to imagine. It is actually, we at Ansys are working on a accurate heart modeling for heart, right, using LS-DYNA in the city office. Now we have this, then the output of this goes into the post-processing, right? You can see the heart stuff, right? Now imagine that somebody, you are a startup, right? You say, I want to build a tool which will assess the surgeon and a nurse in a hospital to do heart surgery for arrhythmia, right? To do a pacemaker in that, right? That's an app. But that app will use sort of Ansys software, software running on this thing, right? Ansys will never build that app because it is just millions of such use cases, right? And the market for each of these apps is at $1 million. It is such a small market. Ansys is not interested. But you are a startup, you are a graduate student, you are a software developer in Bangalore. For you, $1 million is a lot of money. You will build that app. But now we are going to enable you, the app developer, to build the app using Ansys solvers. So is the platform play that we are doing, just like iOS is the platform from Apple, enabling iOS developers to build apps on the iOS platform, or Android developers building apps on the Android platform. In the future, you, the app developer, can build apps using simulation on the Python on the app.
That's an amazing analogy. Yeah,
that is exactly what we are building. So, I mean, is it open source? It is. The APIs are open source.
Sure.
I mean, it's like you use a calculator all the day. Do you know how that multiplication happens in the calculator? You don't, but you don't care, right?
Yeah.
You just type it in and you want the calculator to calculate. That's the API.
Yeah.
So the point I'm trying to say is that, and there is a business for everybody, right? So you, the app developer, will sell that app to the doctor for, say, $500 per operation.
Right.
There is a value to the doctor, right?
Right.
The value to you get $500. And because you leverage it out on our platform, you pay us, I'm just making it up, 25% of the $500.
Okay.
We at Ansys make $125 of the money that you make per operation. Can you imagine the money that will be generated?
Right.
And it will help, not the money that we the amount of, so we call that pervasive insight. Anybody in the world can use simulation.
For sure, this is one of the approaches to get to Horizon 3 innovation. But how do you think large corporations can collaborate with academia to accelerate Horizon 3 innovation?
So that is an absolutely great point, right? So in my book, I kind of talk about how large companies can partner with academia better and how large companies can partner with startups better, right? So I'll address both of those questions.
Sure.
First, academia, right? So one of the things that you can do is to fund a R&D project in academia. So we at Ansys, right? We are funding a project at Stanford, right? So we do a lot of AI machine learning work, right? And we fund a professor at Stanford. We fund a professor at CMU. We fund a professor at MIT, fund a professor at Brown, and so on, like 5-6 universities that we are funding to collaborate in the area of AI, ML, and so on, right? So there is different forms you can do it. You can do with a full research project with all full overhead, and typically a graduate student at university will cost, as I said, $100,000 to $150,000 per year to support one graduate student will full over. It means you're paying for the tuition, you're paying for their stipend and the overhead of 50% overhead to university, and that's what it costs, right? But in exchange, what you have is you have sort of IP, intellectual property rights, right? Say, hey, if something were to be invented at Brown University, then Ansys has a right, a non-exclusive right to their property, right? To their intellectual property, because non-exclusive, but without royalty, right? It's not exclusive. Brown can give it away to Dassault and Siemens and alter our competition, right? Because we are not being exclusive, we're doing non-exclusive, but it's royalty-free because we have paid for the R&D. That's one line in the agreement. The other one is, or an exclusive royalty-based agreement, right? So we're the same thing, we can pay, we can exclusively get that thing, but we'll have to pay some kind of exclusive rights, which is like 2% of revenue or whatever that will be generated. That is what you get with a funded, sponsored R&D project at a university, where you can actually explicitly put in restrictions. Hey, you can publish your work, but before you publish, you need to patent. And when you patent, we have the right to do an exclusive, non-exclusive license, etc. So a lot of stuff involved as part of it. The other thing is, what we actually do a lot is to just give an unrestricted grant, saying, hey, Professor Jack, right? I'll give you this money, 25K, 50K, do whatever, right? And we hope to do collaboration, no strings attached, right? If you want to do this, publish it, patent it, we have no rights to that, right? But I actually like it because it's a lower cost, very agile, because I actually believe that in the software world, all this stuff around patenting and so on, litigation is complete crap, right? I mean, it is about who can build a product faster, bring it to market fastest than anybody else, right? Yeah. So because you're close to the professor at Stanford, right? You're building a product on AI/ML based on these interactions and so on. You build it, you bring a market. We don't care if they license it to Altair and Dassault and so on, and it takes them another 5 years to bring an AI/ML product to market. By that time, with the product will be out, we'll make money and we'll go out, right? This is how model we are saying, unrestricted funding. So we give that 25K, 50K to the professor, and the professor can just say, thank you, Prith, bye-bye, I will not do work with you. Yes, they can do it, but they never do, because it is all about trust, right? I mean, I used to get a lot of unrestricted grants from all kinds of companies, right? Because in academia, it is all about trust, right? When a company has given you money, right? It is just a simple letter. It is an unrestricted grant. You can do whatever. But the understanding is that you will collaborate and all the work that I'm doing, right? We have weekly calls with all these professors. We're doing all kinds of collaboration, except that it's not leveraging, right? So if they want to license it to Altair, go ahead. We don't care, because it is the daily interaction that I'm getting from you, that it is a knowledge transfer that I'm after, right? Not the piece of software. As part of it, I will not get any piece of software officially from that professor. So that's topic 2.
So it's as good as you just paid for consulting calls.
Right. The third thing is, you say you hired this professor as a consultant, right? And we have done that, right? So there are people, right? As a professor, I say, hey, we will hire you as a consultant 1 day a week, and we'll pay you $20,000, right? Per year for the consulting. Now, as a consultant, you are an employee of Ansys. Any intellectual property that you have belongs to me. So we can control that thing, right? So we can hire you as a consultant. Fourth way is this graduate student that Professor Jack you are supporting, right? When he graduates, because we supported your work, etc., and during your PhD, during your summer months, please come and work at Ansys as an intern, right? And you're building that relationship, and then they go back and they continue to do more work and so on. And when they graduate, you're sort of done dating, right, with this person, right? Yeah. You brought them, you've dated multiple times, and you marry, meaning this person joins you.
Yeah.
So there is multiple levels that you can do with funded R&D, funding, unrestricted funding, hiring a professor as a consultant, and recruiting the graduate student into your organization, because the knowledge transfers with the person. That's the academic part. Any questions on academic part?
No. How would you go ahead with startups?
Okay, so the startup is slightly different, because in a academic setting, I said I can have an exclusive royalty-based license of the technology, which is fine from an academic setting. But a startup, if they do something and they license it to Ansys, they are toast, right? Because the large company can do an exclusive license, and then they will not be able to do anything, right? So it is a non-startup, right? So the startups you have to handle it slightly differently. So the way we do startups is, the first thing is, I'm at Ansys, right? I'm a simulation company doing fluid simulation, finite element, finite volume methods, meshing, etc. HPC, high performance computing on GPUs, there's that, AI/ML, working in physics-informed neural networks, data-driven neural, all kinds of technology, right? So I'm digital twinning, model-based systems engineer, right? So I'm scanning the network, right, for interesting startups in this space. So I'm talking to you, you're doing some startup. Well, your particular technology is not quite relevant to Ansys. So today, yeah, I've scanned you. I'm not interested. But if you were to do a startup, right, that is relevant to us, right? For example, I'll just give you an example, right? We are working with a startup called Neural Concept, a startup in Switzerland, right? We kind of came across this startup at a conference, at a Neurals conference that we were at, and they were doing this. So, wow, this is an interesting startup. Hey, the CEO is Pierre. I said, hey, Pierre, I would like to sort of talk to you. So we scan hundreds of startups, and with maybe 5 or 6 of the startups, you say, let's do something together. So it's a technology collaboration, right? Say, let me take your technology, neural concept technology, plus our technology, and try to build something for a customer. Then we take it to a customer. I say, actually, it is a true fact, right? So let's talk about a startup that we have actually engaged with in the past. It's a company called Denardo, the company in Germany that had a product called OptiSlang, and I mentioned it in my book. So OptiSlang is a product which allows you to do what is called design optimization, right? So you can, when you are doing a design of a phone, right? This particular phone is 6 inches wide and 3 inches long. Now, should it be 6 by 3, or should it be 9 by 4, or should it be 2 by 6, right? There are all these choices. There are thousands of parameters, sort of design cases, from which the most optimal design is 6 by 3. Denardo had a tool called design optimization called OptiSlang, where a designer would say, here is these different parameters, right? And say for I equals 1 inch to 6 inches, for J equals 3 inch to 9 inches, or an increment by 0.1 inch, right? And you do the design, and inside that you run a solver, an Ansys mechanical or a Fluent or whatever. Each of those things are taking like a 1,000 hours, right? So that generates 1,000,000 hours of job. That is good for Ansys business because the customers are using thousands of runs of Ansys solvers, and it's good because it creates a workflow where instead of the user having to do this with Python scripts, it is done by a tool. Now, right. I obviously give you a very simple thing. You would say, why would I buy OptiSlang? But that's the concept, right? It allows you to design optimization. So we found this company. I said, oh, that's kind of interesting. Why don't we take you to a customer, right? So it's OptiSlang plus mechanical to do design optimization. And he said, oh my God, that's really interesting. So then we said, hey, your technology, you're trying to directly sell your technology for $50,000. If we, Ansys, were to sell your technology, right, as a white label, it becomes a part of our product, right? And we'll sell it for 50,000, but you, Mr. Owner, you get, I'm just making a number, right? 25% of it, right?
Sure.
So you may say, oh my God, it is my IP. You're only giving me 25%. That is sort of short-term thing, because if you think about it, the Ansys brand, I mean, Denardo could not have got to that sale, right, without the Ansys too. We have like 2,000 salespeople around the world, right? So once we put it on our price list, it is enormous, right? So the next step is what I call a business partnership, which is an OEM agreement where we put their product on our software, maybe integrated with other tools and so on as a workflow, and our people sell it. Then we see, well, yes, year 1, we had $2 million in sales. Year 2, we had $5 million. You know what? This is a good thing. Maybe we should buy you. So then the next thing is to buy the company. And as part of it, in the middle, you needed some money, you are raising Series B money. Hey, we will fund you as part of, we'll give you $2 million as part of your Series B funding, right? So multiple stages. Stage 1, scan the startup. Stage 2 is engage with the startup in a technology collaboration. Stage 3 is a business partnership, an OEM. Stage 4 is an investment in the company, right? Stage 5 is acquisition.
Right.
In the last 5 years at Ansys, we have acquired more than 20 companies.
Wow, that's almost 4 every year.
That is exactly 4 every year. And every one of these is a Horizon 3 disruptive innovation for Ansys. So we are practicing what I'm preaching in my book.
Wow, wonderful. So what you're essentially telling is that big corporations have already a distribution. They have access to the audience and the users and the market. There is some kind of Horizon 3 innovation that these startups have. And these startups can use, let's say, a corporation like Ansys or ABB as the wedge to the market.
Absolutely. And that's exactly what BioNTech did with the COVID vaccine with Pfizer. The day the COVID vaccine happened, the CTO at Pfizer knew that this mRNA vaccine is the way to solve it, and BioNTech is the company that has invented it. So he immediately reached out that same day when the COVID became a thing. He reached out to the owners of BioNTech, say, hey, you have this thing, would you like to do the partnership? They did the partnership, and fortunately, Moderna is did not do a partnership, right? So we'll do it all by ourselves, right? So they had a very long path to go.
Yeah.
BioNTech did a partnership with Pfizer. It looks, Pfizer had a vaccine. Pfizer did not have the vaccine. It is BioNTech's vaccine, right?
Right.
But you and I, we are saying we're getting the Pfizer vaccine or the Moderna vaccine. The Pfizer vaccine is a BioNTech vaccine. But Pfizer practiced open innovation by doing the partnership and doing the hard work of getting all the clinical trials, right, with the FDA, because they know all the FDA people, they can jam it through this thing, right? So the Pfizer got approval faster than Moderna and so on, right? Even today, in Pfizer, in terms of market share, is larger than Moderna. Sure. Not because Moderna is worse or whatever, but because of the scale that a large company brings. So all I'm saying is you need to have a partnership. So if Pfizer said, oh my God, I will beat my people, invent the vaccine organically, right? That is also the wrong approach, right? You may not be able to do this, right? And so what I say in my book is, in order to do Horizon 3 innovation, right, you need to have a central research lab like an HP Labs. So at Ansys, I have a team that is doing healthcare. That is a team doing digital twinning. I have a team doing AI, ML, and so on. So I have my own people doing my own stuff. But I'm also, this central team, I'm encouraging them to partner with academia, working with, so it's not just my own team. My own team expanded with all the people in academia and the graduate students and so on, right? And with startups like the Neural Concepts and 5 other startups. And with large companies, we are working with NVIDIA, we are working with Google and so on, right? Bringing all those things in, not just a central research. But if you don't have a central research lab, right, at Ansys, then who at Ansys will know which AI/ML professor to work with, right? Because if the people are all busy writing code with a release date for the R1 release. We just had our R1 release yesterday, right? For 2023 R1, right? If everybody is a developer, nobody will have the time to do this partnership with these universities. That's why you need a central research lab. That's why you need a CTO office with a central research lab. But you should not expect the central research lab to do all the innovations and in the COVID vaccine, right? Their job is to do some innovations themselves, work with BioNTech, right, and integrate, like what we did, Ansys Mechanical plus OptiStang into an overall tool, then bring it to market. That is also innovation, right? So avoid the not invented here. Oh my God, I didn't do it myself, therefore it's bad. No, you should be equally incentivized, right? If you are a researcher in the central research lab, right, you should get as much credit in inventing it yourself as in identifying a person to bring, right? So I give an example in my book, right? When the NFL teams, right, they hire these absolute phenomenal players, right? The quarterback or the running backs and so on, right? There are these people that are scouts that go to high schools, right, and watch hundreds of games, and from those games say, this kid is really good. And then they do the NFL draft, right? So they're essentially doing open innovation, right? They're not trying to grow their talent, right? Hire these people like junior people to 12-year-olds. They're just tapping the source from these high schools, right, to find the best talent, right? So I'm just giving multiple examples to make the point of open innovation.
Yeah, it becomes very clear. But one thing I want to ask here is another approach that, let's say, Ansys or any corporation could take is you invest in an in-house research team that also focuses on the innovation. Now, I understand the differences. The moment you sort of look at this as outsourcing to a certain startup, when you're initially engaging them, licensing their tech and all of these, you're sort of putting the owners and the liability on the startup and reducing the liability for the corporation. But from the longer term perspective, when you're telling that, the fifth phase of this collaboration is ultimately going to be an acquisition, from that standpoint, don't you think it's much better for a corporation to invest in an in-house research team for over a couple of years, like let's say what Twitter did with Blue Sky, or what Meta might have done with, or what Facebook might have done with the Meta team that was working on the metaverse tools and the Oculus and things like that.
Absolutely. So I'll tell you, look, I worked at HP Labs I was the head of HP Labs. We did a lot of Horizon 3 innovation at HP Labs, right? We were a company the business were PCs and laptops and printers and servers, right? And we were doing innovation around crazy stuff like the memristor, right? A non-volatile memory. Absolutely innovation. We had no route to market for those products, right? So those innovations just died at HP Labs, right? So the other thing that I kind of say in my book is, if you are creating a central research lab, you also have to have your sales and marketing arm to bring to market these absolutely innovative products, treat it like a startup. So you have to do all of those things. You have to invest in organic R&D, as you said, with Meta and Metaverse and so on. You have to invest in your own sales and marketing for those R&D teams if they're successful, and fund those internal projects just like a startup. Just like a startup gets Series A funding 5 million, Series B 10 million, Series C 20 million, and so on. In that internal R&D in HP Labs or Ansys Labs, you fund that project initially with 5 people, with some milestones. You work on it for a year. And then once the milestone is done, you grow the team to 10 people, and you give them another 18 months and grow the team to 20, 30 people. But the other thing is, when that project is not successful, you kill the project. You don't add the people, you ask the people to pick something else, right? That decision to do this gated thing is the most important thing that a VC does. A VC knows when to pull the plug from the startup. As a head of HP Labs, I had to have the discipline to pull the plug, and I did on projects. And as CTO, that is a very, very important role you have. To keep funding more as it's growing and pull the plug when it's not.
And okay, for sure, you might have a certain roadmap and some targets and milestones telling, we might want to achieve this by this timeline. But how do you really evaluate if it's okay to give a little bit more relaxation, or if you should pull the plug?
And this is precisely what I said. Innovation is not like bricklayer, right? You have 200 bricks a day. Therefore, I will lay 2,000 bricks.
Yeah.
So, you have to let some risk tolerance, etc. So it is a complicated game. This funding R&D for Horizon 1 is very predictable. Funding R&D for Horizon 3 is like putting bets. And this is how VCs, they make a ton of money, right? They invest in 10 startups and only one is successful. That one that is successful is hugely successful. That is kind of the lens of risk-taking and innovation culture that you have to build in your organization, in the organic people.
Got it. Since we are on the clock, just a couple of questions, maybe give 1-line or a 2-liner answers to this. If you were, let's say, a 20-year-old or 21-year-old and you just graduated out of college, what would you do? Would you really do a PhD and go into academia? Would you start up? Would you take up a job in a leading industry? What would you do?
I know why you're asking the question. I think there is no one answer to innovation, right? We have to allow for multiple paths, and these different paths some of them will actually work through the PhD, through the academic and so on, right? Not all innovative products require deep PhD level innovations, right? I mean, you can have a very simple innovation like the concept of Uber, right? Let's create a platform, right, to hire a bunch of people as drivers, and they provide it to customers, right? That doesn't require a PhD. It's the innovation, right? But then when you try to really do the deep analytics as to connect up sort of Prith, who's the customer, right, having this particular requirement to Krishna, that might require the PhD. So not every innovation requires deep sort of technology. Like for an innovative thing like a James Webb telescope, a 20-year-old without a PhD cannot do the James Webb telescope. I can guarantee you that, right?
Right.
So to do a thing like a SpaceX rocket, you cannot do without a PhD.
Right.
So depending on the innovation, right, There are some absolutely innovative things that you do for AIML that you will need the PhD in AIML. Others where you have to have the sort of business sniff, right? To pick a interest, like FedEx, right? As a business model, right? Let's just do overnight delivery and so on. Doesn't require a PhD. It requires business insights. But there are things like James Webb Telescope and the Blue Origin and the SpaceX and so on that does require PhD.
But at some level, would you say that at this stage, let's say in 2023, there's not much innovation to be done in terms of business models, and any sort of innovation whatsoever has to happen at, let's say, the tech levels or at the Horizon 3? You wouldn't say that?
I would not say that, because, I mean, the FedEx thing came out of a need, right? Somebody was trying to say, you know what, I want to ship this overnight, right? It was a business need, right? So businesses will always have needs in the future for crazy stuff, right? I mean, I would not say there is no business. The smartest innovators are people that recognize a business need, right? Like when Amazon was founded, right? Bezos found, I mean, there was Barnes and Nobles and so on, but there, he you know what? I'm trying to get that unique book, right? And I cannot find it. So they started as an online book retailer, right? And that was the business what he was trying to solve. And then obviously through all kinds of AIML and so on, he made it much better. Then he says, you know what? Why only restrict to books? I can sell anything, right? So in a typical Walmart store, I mean, you're in the US, you know, Walmart, you go to Walmart, there are 200,000 things on a Walmart shelf across the 5,000 stores on Walmart, right?
Yeah.
200,000, right? So you want to buy Tide detergent? Yes, it is there. You want a Tide detergent which is 14 ounces? Yes, you have it. But you want the 46 ounce? I go to Walmart to find it. You type it on Amazon, you find it. So Amazon has 2 million SKUs on their portfolio, right? Not 200,000.
Right.
10 times more, 100 times more, and so on. That is the business need he identified. And he said, but how many people will need that 56 ounce Tide, right? Only one people, and maybe in Nebraska. So because of it, does Walmart put that thing on the shelf, which is very expensive in Nebraska, knowing that you may need it in New York? So the online absolutely makes sense, right? That is a business need. So it is, will never say there's no business need for innovation. There's always going to be a business need for innovation, right? But there are things like the thing that I talked about, the absolute autonomous vehicle. Somebody will absolutely create an AV car, right? With level 3 autonomy, level 5 autonomy. That will not happen with a 20-year-old. That will require the deep AI needs and so on. You need both.
Got it. And just a single line of advice that you would give to a 20-year-old today who's fresh out of college?
I would say the most important thing is keep innovation in your heart. Be passionate about innovation. Don't limit your thing to doing incremental things in life. That is a thing. Dream big, be passionate about innovation. That is the mantra that I have followed throughout my career.
Wonderful. Very, very deep and thoughtful conversation, Dr. Prith. Really enjoyed this. Thank you for doing this.
And thank you for reaching out to